Have you ever noticed that the trip back always feels shorter than the trip you took to get somewhere? Researchers have actually looked into this phenomenon. It's called the return trip effect, and the explanation is a lot less straightforward than you might think.
This is a very universally felt and experienced effect, whether you're flying in an airplane or you're exercising.
Yeah, you would think that there would just be an answer, and it's a lot more complicated than that. So scientists already know that your sense of time is really flexible. Sometimes it feels like time speeds up or slows down based on what you're doing. But researchers can't agree on what exactly a return trip does to your brain to make it feel so short. Here are a few hypotheses. The first explanation is that the return trip is just more familiar. That's what I thought. A 2016 study published in the journal Hippocampus had participants sketch a map of their campus and write down travel time estimates between different places. The more familiar a student was with the area, the shorter the travel times they estimated. The familiarity hypothesis makes sense, but the next idea contradicts it. Explanation number 2 says that you overestimate how long the return trip will take. A 2011 study had participants watch videos of someone else traveling, and they said the return trip felt shorter, even when the return trip was on a completely different but equidistant route. The researchers thought this might be because you underestimate how long you think it'll take to get to your destination. So when it takes longer than you thought, you end up being disappointed, and that makes you more likely to overestimate how long it'll take to get back. When you overestimate the return trip timing, the trip back feels delightfully shorter. But there's still a third possibility out there. That says the anticipation of your destination affects how long the trip feels. Researchers for a 2016 study put students in a room in a lab, then took them to different rooms where half of the students knew what they'd be doing there and the other half didn't. Then they went back to that first room. The participants who didn't know what to expect when they left the first room judged the initial trip to be longer than the trip back, which suggests that the initial trip feels longer because you don't know what to expect when you get to your destination. At the end of the day, all three of these hypotheses have one thing in common. Whether it's familiarity, overestimation, or anticipation, they all suggest that time seems to move more slowly the harder your brain is working. It's clear in any case that your brain is playing with your perception of time. So in the end, maybe it's just best to be happy you're finally home.